Okay, this is video 13, tangent planes, and it's a good one. I think we'll get some GeoGebra in there. So we start off by, we let f of xyz equals c be the level surface of f, and r sub t is some curve r sub t is some smooth curve on this surface, right? Then, if I evaluate f at these three functions, it equals c. And so this equation here, I'm going to call this equation 1. We're going to differentiate both sides of 1. And so on the left-hand side here, we use the chain rule, and got to be really careful here. So it's df dx partial times dg dt ordinary plus df dy partial times dh dt ordinary plus df dz partial times dk dt ordinary, and the derivative of c is just 0. Okay, so this turns out to be, we saw this before, this is a dot product. Okay, it's a dot product, so let's write it as a dot product. On the left here we have this guy, and this guy, so that's del f. And then dg, dt, dh, dt, dk, dt, that's just the tangent vector, dr, dt. And their dot product equals 0. Okay, it says they're orthogonal. And this is just any old curve in 3 space. We just parametrized it and on this level surface. So at some point, P naught on the curve, or del f is orthogonal to dr dt. Right? So this says that all the velocity vectors, all the dr dt, all the velocity vectors at p naught are normal to del f. And if you take all the lines, you get a plane. And so all the tangent lines at some point on the surface lie in a plane normal to del f, and this is really key. Okay, and this plane is called the tangent plane. Okay, which I'll define now. The tangent plane at some point P naught, which has coordinates x naught, y naught, z naught, on the surface f of x, y, z equals c of f is the plane through P naught, normal to, not normat, not normat, normal to the gradient vector f, del f, evaluated at P naught. So this is the tangent plane, okay? And the equation of this plane is, well, it's the x partial evaluated at P naught times x minus x naught plus the y partial evaluated at P naught times y minus y naught plus the z partial evaluated at P naught times z minus z naught, and all that equals 0. Okay, so that's the equation of the tangent plane, and the normal line which of course is parametrized, is x naught, y naught, z naught plus f sub x p naught t, f sub y evaluated at p naught t, and f sub z evaluated at p naught t. Now note, these are the same. Okay, so once you find the normal line at a point on a surface, you get the actual equation of the plane almost for free. Okay, this really gets fleshed out on the examples. So let's do some examples here, and because we've done a bunch of tangent lines, and all I'm going to do now is go, oh well, all those lines lie on a plane, and we're going to graph that. So here's our level surface. So we want to find the tangent plane and normal line of the surface f of x, y, z equals x squared plus y squared plus z minus 9 equals 0. Okay, at the point 1, 2, 4. 1, 2, 4. Okay, so solution. Well, we need del f, so del f evaluated at 1, 2, 4 is, let's see here. Plug in 2 and 4, and you get 2i. Plug in 1 and 4, you get 4j, and then 4j plus k. Okay. So that's our that's del f, and so here's the equation of the plane. It's f sub x times x minus 1 plus f sub y times y minus 2 plus z minus 4 equals 0. And it's good form to clean this up, so you get 2x plus 4y plus z equals 14. And that's the equation of the plane. So the planar equation. Now let's find the equation of the line. X, y, z. 1, 2, 4. plus 2t plus 4t plus t. Okay. All right, so let's have a look at this thing in GeoGebra. See if I can't screw this up. All right, so you hold this. Nope. Come on. And you go all the way over there like that, and it opens. Yes. Delete. 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 Okay. So first we're going to put in, where the hell is it? There it is. Solving that for z, you get z equals 9 minus x squared minus y squared. And can I make this bigger? Stop moving. This makes well, it makes it's chopping the top off. This makes a cone. Okay, so let's put our point on there. 1, 2, 4. It's up there. Okay, what else do we want to put on here? Not that. One, 2, 4. We want to put the plane on there. We want to put the plane on there, so that's 2x plus 4y plus z equals 14. All right, I want to get this cleaner than I have it. So let's see here. I want to go away. There we go. Can you get smaller? That's it. Now spinny spin. That sure as hell doesn't look tangent to me. Did I get the point wrong? No? Ah, I see it now. I'm sure all of you are looking at it saying that you see it. So this is supposed to be a Z. That's better. Okay. And now you can see that the plane is tangent at the point A, and you can see there quite clearly that it's a tangent plane at the point A. Okay. So now let's put in this normal line. So it's 1 plus 2t, comma, 2 plus 4t, comma, 4 plus t. All right, I'll get rid of that, and you can see that all the tangent lines lie on this plane, and that this normal line here is perpendicular to all of them at the point in question here, which is 1, 2, 4. Okay, so that was fun. Let's see if I can do this. Nope. And gone. There you go. Okay. So let's do another example. This one's even funner. Example 2. Now we're going to take two surfaces. We have f of x, y, z equals x squared plus y squared minus 2. So set that well, you pull the c over. This actually makes a cylinder. And then the second guy here, x plus z minus 4 equals 0. There's a plane, right? Because it's all linear. Okay, these two intersect. In an ellipse, which we're going to call E. Okay. All right, what we want to do is find parametric equations for the tangent line to this ellipse E at the point P naught, which is 1, 1, 3. All right, so this is where picture drawing becomes important. And then we finish it up with a look at GeoGebra. So I need a whole screen here, so I'm gonna push this out like that. All right. So let's see here. I want to make this pretty. I wanted you to go away. There it goes. Okay. So there's the z-axis. There's the x-axis. There's the y-axis. All right, this cylinder, where is it? I'm looking right at it. It has no z-coordinates, so that means z is free. So basically, it's the circle x squared plus y squared equals 2. So it's a circle of radius root 2. And then this thing just goes on forever. Actually, right? That's all we need is that little bit there. Okay, the plane x plus z equals 4 has no y in it. So I'm going to use some colors here. And it comes like this. So here's the plane. And let's get one more color in here. Where it meets, where it cuts through here is an ellipse, and there's the ellipse E. Okay. So think about having a sharp knife, you're cutting through a zucchini, and this is what we've done here at a little bit of a bias, and so instead of making a perfect circle, we get this ellipse E. Okay, so the point in question is where is it? I lost it. There it is, P naught. So here's P naught. It's 113. And what the problem is asking is to find the equation. So here's the tangent line here. We're going to call it L, right? So we want the equation of this line. Okay, remember what we need for a line. We need the point, which we have. So when we're done, we're going to have x, y, z. So we've got the point, don't we? It's 113. And all we need is a vector that's parallel to L. Call it V. So this will be TV1, TV2, TV3. Excuse me. So this is where the fun begins. And it's going to get ugly, but so perpendicular to this point on the surface, going out here, is del F. Right? And perpendicular to the plane, going this way, is del G. And they meet at P naught. Okay? They're perpendicular to each other. So if we want to find a vector perpendicular to both of them, then what do we want? We want the cross product here, like this, right? And this is the vector del F cross del G. And that's the V we want. All right, this is going to be parallel to the line. And so you do the cross product. So you go del F cross del G, and you do your matrix after you find del F and del G, and you wind up with 2i minus 2j minus 2k. So this becomes 2 minus 2 and minus 2. So let's make that prettier. I want to leave it all up there though. So I'll use some erasing. Go. So it's 2t minus 2t minus 2t. And there's the equation of the line. This line L here. Right? So we used, just like before, we used this vector, del F, which is perpendicular to the cylinder, normal. And then we took this del G, which is perpendicular to the plane. And they're perpendicular to each other, so when you cross them, you get this guy here. Or even if they're not perpendicular to each other, which they aren't. They are. Never mind. It doesn't matter. When you cross them, you get this guy. Del F cross del G, and that's the vector we want because it's parallel to L. Okay. These problems are really, really hard to sort out. I mean, the math is super easy, but getting this picture to cooperate and see what you're looking for is tricky sometimes. I want to give you all of homework 7, even though we haven't done one of the sections yet, just so it's all in one place. So 14, 1, 4, 9, 12, and 16. And section 14.7 is quite large. 2, 7, 12, 17, 24, 34, 37. I'm going to put an asterisk on that. 42, 46, and 62. So this guy was an old midterm problem. And when you get to doing it, I mean, we won't even get through the material until Thursday or Friday. So just remember when you see that's about the level of stuff I would be asking on a midterm. Okay, have a great day.